Hi there, my name is Dave Marisek, and I modeled the Columbia and Western Railway in 1901 in virtual scale. The Columbia and Western, which was owned by the Canadian Pacific Railway, ran from Rosslyn, BC to Midway, BC, approximately 132 miles, in 1901, with a barge connection in West Robson. This view here is the view of the Smelter Junction yards in Trail, BC. I modeled the Columbia and Western as I grew up in Trail, BC, and the railway ran past my bedroom window. My dad worked at the chemical smelter, and I also worked there as a student engineer. I model in V-scale as I can build full-size railways and industries to prototype. I use Trainz software, and I model the Columbia and Western on a 1:2 scale. I also operate on a 2:1 fast clock, so that all of my trains can run to prototype timetables. This is the view of the smelter in 1901. The copper smelter is directly in front of us, followed by the lead smelter. This 30-minute video will cover the CPR Smelter Junction and the Canadian Smelting Works at Trail, BC in 1901, with a focus on what I learned modeling the prototype. We'll cover off 5 topics: researching the smelter junction in 1901, a drone view of the layout, the CPR timetable and train operations, the Canadian Smelting Works copper smelter and train ops, and the CSW lead smelter and train ops. Currently we're riding on the Smelter Junction yard engine number 318 as we just passed through the yard from the CSW yard up through to the CPR yard. The first topic I'm going to cover today is research. I'm going to cover 6 different sources of research that I've used to establish the prototype for 1901. The first thing I use is images from historical associations. So these are 3 images I have from the Trail Historical Association. The first one is the smelter. The date on this is probably post-1906 since the concentrator is far off to the right and it was built in 1906. On the right side you can see the lead refinery and the silver refinery at the very, very far right side. Then we have a few view in the middle there is just the yards. We can see the main copper smelter, which is the stack to the left, and then the copper mat building, which is what we're seeing right up there against the river. Behind it we see the lead stack, and off far to the left we see the town of Trail. The next image is looking from the south side. This image I believe would be close to 1900 because the refinery buildings do not appear to be built yet. So this would be in the process of rebuilding 1899, 1900. To the far left you can see the 2-story station building. It looks like an office building, but it's actually the station building. We can see the copper smelter to the right with the copper stack. In behind it we have the lead smelter with the lead. The stack that's in the center is probably the lead roasters, though it could be also something to do with coking. The next image is we're down at the river level. Trail is to the lower left, so you can see where the town of Trail was relative to the smelter. Great picture here of both stacks. The copper smelter, which is the older smelter, is the center of the picture. Up to the right side, you can just see a trestle with some cars on it. That would have been the copper mat load for box cars. And off up to the upper left, you can see some ore cars. That would have been the low-grade copper ore coming down from Rosslyn. The next source of pictures that I use are track diagrams that I get from the Canadian Pacific Historical Association. This track diagram is Smelter Junction. It's straight even though Smelter Junction is 180 degrees on a curve. This one is definitely post-2000 or post-1916 because it has the zinc smelter tracks on it, and the zinc smelter was built in 1916. However, it gives you a feel for the amount of trackage at Smelter Junction. The diagram that I use more frequently is someone has redlined this diagram to show where the original Columbia and Western went, and that's what I use for 1901. So we have the red lower loop there at the bottom, which is the low-grade copper ore loop, and it also was the station was on that loop. And we have the Y coming off the CSW yards at the beginning here, and we don't have all the zinc tracks. It's also useful is off to the left side we can see the coal. There's a statement for coal. We can see the water tower just below Tadnak. We can see the engine facilities, and we can see the smelter yard leads. The next type of documents I use are pictures, and these are from Heckman's Canadian Pacific book. Most of his pictures are 1900, 1901. So this was West Robson in 1901. I use this so I can see a picture, what does the track look like? So 58-pound track, but you'll notice there's no ballast. So back in 1900, they shoveled the dirt between the rails and they shoveled the dirt between the tracks. So when I model Smelter Junction, I'm using this sort of fill for the track work. The other thing that Heckman gave me is, what do the boxcars look like back then? So this is a picture from 1901 on the main line, but you'll notice all the boxcars are Canadian Pacific. Two of them stand out with the white lettering and the Tuscan brown. The other two, you're going, what are they? Well, they are Canadian Pacific. If you look at the third boxcar, you'll see, you can just barely see the Canadian Pacific logo in the color black. So it appears that sometime in the late 1800s to 1900s, they changed the color of the cars and they went from black lettering to white lettering. So this gives you a mixture of, these trains seem to be, in 1901, about 50-50 of the old cars and the new cars. Next thing I look at is motive power. So this comes from Doskin's Railways of the West Kootenay Part 2. And this is a list of motive power that was sitting there in pre-1901. As you can see from this, it's all 280s. So as I model, I use 280s, and I use the train numbers that 318 through 771 on the engines. Next, train schedule. So this again from Historical Associations. This is the time bill number 16, Canadian Pacific Railway Pacific Division, March 25th, 1900. As you can see for Rosslyn, there were only 4 scheduled trains, 2 north, 2 south. For my purposes, I only model from 7 in the morning till 5 p.m. at night. So number 61 I will model, and number 62 I will also model. And there's no activity on the trail section for scheduled trains in those hours. Lastly, and most importantly that I find most useful, is how does a smelter work? So this is a wonderful article from the Engineering and Mining Journal, July of 1923. 11 pages describing the trail smelter. And this gets right into everything from what they were producing, what they were smelting, what type of ores they were using, what the equipment was in the different smelters, when things were built, where the ore was, which mines were producing. And this is my primary document that I've got off the internet. So those are all my documents that I use. So what did I learn from all this research? Well, the first thing I learned is that finding material very specific to a year like 1901 is difficult. A lot of the images and materials are later era, 1910, 1920, and it's hard to figure out what year the pictures are in a lot of cases if there's no number. But also, are they actually accurate? And was that actually what was built at that point? So by using a combination of all 6 different types of research, I get close. And I think that is what this is about. It's enough material to get close. Does it look and does it feel like the pictures, like the images? Does this feel like 1901? Everything from the griminess of the smelter, to the track, to the engines, to the cars, to the activities. Okay, we're going to start our drone view from the north end of the Smelter Junction. We're here at Stony Creek, which is just before the yard limits, and this is the Stony Creek Trestle. So we'll just fly in here slowly. Here's our north yard limits for the smelter. As we get up to the first set of tracks, these are the CPR yard tracks at Smelter Junction. The tracks to the left are outgoing northbound trains. The tracks to the right are southbound incoming trains. And we'll get into the yard operations a bit more later on. Off to the left there you see the substation with all the electricity coming from Bonington Dam up on the Kootenay River. First spur off to the left is going down to the lead load. And the first building we hit here is the silver refinery. And a little further along we have the lead refinery. Just past the lead refinery here we actually have the Columbian Smelting Work Yard. So there's 4 yard tracks to the left and there's 2 ore tracks to the right. All the switching for the smelter is done from these tracks here. We also have the Y off to the right. And then we get into the smelter leads itself. We have 4 leads into the smelter. First lead over here, far to the left, is actually the copper mat load, and it's the longest lead going all the way down to the copper smelter. Next lead over is the coke and limestone unload lead trestle. We move on further, and with the box cars is the lead ore unload. And the box cars in the distance is the copper high-grade ore unload. Just moving through here. What do we have moving below us? That's the smelter yard engine just moving below us, a 280. Once we get into the smelter, I'm just going to have to go up a bit here just so we can clear the buildings. The smelter, this is the lead smelter we're passing over. So the lead smelter runs along here and is the newest smelter that was built in 1898 to 1900. So this is all lead and up into the lead anode building. Just below you can see the tracks for the narrow gauge railway. And over here we have the older copper smelter, the matte building, the copper smelter across the end, and we have the copper ore bins on this side here. Sliding back a bit, we have the engine facilities. This is the CPR 5-stall engine house. We have the repair and replace tracks and the heavy repairs that are done here at the trail. We got the sanding tower. Moving across here, we on the main line has a water column, and the the CSW line has the water tower. We hit to the station. The station is actually not on the main line, it's on the copper loop. This is because the original Trail Creek narrow gauge railway came to this point and then did a switchback heading up to Rossland. So we have the station, and it's a 2-story building because the Columbia Smelting Works offices are in the second level. And as we move forward here, we hit the coaling facilities. And as we move out in this direction, we hit the yard limits to the west, and this is going up to Rossland. So Rossland to West Robson was the main line. So this would have been our main line coming through here. In front of us, this is actually the trail spur, or the trail branch as it was called on the timetable. It comes down a fairly steep trestle across Trail Creek, through a switchback, and then down into the town of Trail. The next topic we're going to look at is the CPR Rossland section train sheet for September 1st, 1901. If you recall from the train bill, the only 2 scheduled trains we have are second class number 61 and second class number 62. What we've now added is we've added the mainline extra trains 787 and 771 going north, and 786 and 767 going south. We've also added now the locals, extra 733, extra 111, and extra 318, which are staying within the section. And lastly, we have the work extra 315 and work extra 316 on our train sheet. Okay, we have engine number 111, a class S1A 0444, built by Lima, delivered in 1900 to the CPR. We have a clearance form for engine 111 with 4 orders. Our first order is to run extra from Smelter Junction to Rossland and return to Smelter Junction. We have a hold at Union Avenue siding waiting for extra 733. We also have a warning here that to proceed through Tiger Tail with a... Next engine coming out is engine number 787, a class M1 280 built in 1900. And we have a clearance form for 787 extra with 4 orders. We have a train order running extra from Smelter Junction to West Robson. We have the order that allows us to double between Janelle siding and Potpourri siding. We're being asked to take the passenger siding at West Robson. We have extra 111, our ore train, just leaving the Smelter Junction yard, heading up towards Rossland, just traveling over the Trail Creek trestle at this point. The trip up to Rossland will be a 4.5% grade. We have train orders that allow us to go to Rossland, and we have a train order stopping us at the Union Avenue siding, which is near the top of the hill. Extra 787 is just departing the north end of the Smelter Junction yards. We have a train order that authorizes us to proceed to West Robson and double between Janelle and Potpourri. Today we're pulling a mixed freight. The first 4 freight cars are full of lead ingots. The remainder of the train is empty box cars heading back for more ore or general goods. Engine number 720, which is a class M1 280 built in 1899, just backing out of the Rossland engine house here. We're up in Rossland. And we have a clearance order for engine number 320 to pull scheduled train number 61. We have orders that allow us to pass at West Robson on the passenger siding, with 62 being held. And we have a temporary slow order at the usual spots with... Okay, number 61 is arriving at Smelter Junction. We're running a little late, and we've arrived late by a couple seconds. At Smelter Junction here, the 280, number 720 M1, will uncouple as the engine was used for pulling up the Rossland grades, and we will have engine 194 pick things up. Engine 194 is a Class C2 460 that was built in 1897. This is the engine that will pull number 61 all the way from Smelter Junction to Midway. So we've just, everybody's just boarded the train here at Smelter Junction, and we will be heading off. Next stop will be Murphy, with the next major stop being West Robson. Okay, we have engine number 771, a Class M2 280 built in 1900, just coming out of the engine facility. We have a clearance form for 77 extra 1 extra north with 4 orders. First order, run extra, Smelter Junction to West Robson. We have a stop. We have to double between Janelle Siding and Papuri and hold for 787 to clear. We have extra 771 leaving the north end of the Smelter Junction yards across the Stony Creek Trestle. 771 extra is cleared through to West Robson with doubling between Janelle and Papuri. We're pulling today, the first 4 carloads are copper matte, so they are full loads. Then we have 4 empty coke cars. CP used stock cars to haul coke in 1901. And the last 4 cars are coal cars, empty coal cars going back to the East Kootenays. Okay, we have a clearance form for engine number 737 to pull scheduled train number 62 from West Robson to Rossland. Number 737 is a Class L5 280 built in 1899, and as you can see, we are just picking up passengers here at Robson. We have number 62 arriving from West Robson at Smelter Junction. It looks like we are running late by almost 6 minutes, 5 to 6 minutes right now. It was due here to 11:12 and we're sitting at 11:17. So we'll call that one 5 minutes late. So what did I learn about trying to operate to prototype timetables and train orders? Well, getting to that extra siding, getting the extra to the siding 5 minutes prior to a scheduled train is difficult when there's very few sidings, and it really slows down the movement of extras and work extras trying to get there, so we have quite a bit of holding time in sidings. Doubling takes 30 minutes and adds 30 minutes to your schedule. So it automatically just slows down everything. The biggest thing is temporary slow orders, and the one specific in this route here, which we had 4 of them for 6 miles an hour at the different bluffs, really slows down the whole operation. It adds a lot of time to the schedule by the time your caboose clears the temporary slow order and you get back up to speed and just in time to slow down again. So it really impacts how things move through the operation, how many trains you can move through, and how you get everything moved on single line track that you need to move in a day. Anyway, it's been a challenge, but we are operating, we are running to schedule, and we have trains running. Okay, it's now time to take a tour of the CSW copper operations. We'll start here with the ore unloading bins. To the left of the building in front of us, you'll see the box cars, and the box cars are bringing copper ores, high-grade copper ores from the boundary district, so from the Phoenix mines. They're brought over in box cars with the high-grade ore. There's also some high-grade ore coming out of sacks out of the Rossland mines. So the left side is unloading high-grade ore out of copper sacks that had to be done manually. The right-hand side, we have the copper ore bins. This is for the low-grade copper ore coming down from Rossland in the ore cars. So the ore cars could be unloaded directly into the bins. Both sides of bins go up into the loading facilities and drying facilities. From there, we have trams that will send it here to the next building, which is a crushing building. So this building here is where crushing down to a 4-inch sample size, and they use a Wiesen sampler for that. And again, after it's been crushed, it's trammed down further into more storage bins here. We also add in the limestone here. So the limestone is the flux that's required to get the smelting process going. From the bins, storage bins, and the sampling, we head over to the sintering plants, which are in the main smelter. The sintering plant used Dwight and Lloyd sintering machines, and they used to desulfurize the copper ore. So this is where all the sulfur going up the stacks was coming from the sintering process. After the sintering, coke was added, and then it was moved on to the copper blast furnaces. So they were 600 tons daily per furnace, so we had 3 furnaces going. So the blast furnaces, and from the blast furnaces, they were tapping matte, which was 18% copper. Once it was tapped, cooled, it was moved over to the next building here where it was granulated, put into sacks, and then we load into the box cars for shipment to either Tacoma or Butte. Okay, we have yard engine 318 is on the high-grade copper ore trestle. Just backing up to pick up the empties. We have 8 empties here from the copper. These box cars will be recycled through and used to move other goods. As you can see off to the left are actually the copper ore bin storage. To the right is the lead smelter. So this trestle is just kind of squished in here at the end of the track. Okay, I think it looks like we've been coupled. And be off here. Okay, we have yard engine 318 just approaching the low-grade copper ore unload bin with our ore train from Rossland. We have the bins here, so we will go over each bin. Each car is unloaded with manually, and that all the doors have to be uncranked by people. So this process takes about half an hour to go through here, getting each car done. 12 cars takes about 2 minutes per car, and then we have to clear the bins before we can head back over. So as I was saying, this whole process from picking up the cars and the CSW ore tracks, crossing the main, crossing the yard, getting over to the ore bins, unloading all the ore cars, and then moving them back up to the empty ore track. It's about a 45-minute process, so we have to get this done before scheduled number 61 shows up in Smelter Junction. And the good news at this time, all of the extras have cleared Smelter Junction, so we have room to operate in the yards. Yeah, we are at the copper matte load trestle. We have 4 box cars of copper matte that are loaded full and will be heading for either Butte, Montana or Tacoma, Washington. The yard engine will pull them all the way up the trestle and deposit them in the CPR northbound yard. Now we'll review the CSW lead operations. Lump lead ore from St. Eugene mine in Moyi and the Slocan mines was shipped in sacks by boxcar. Also from the Amesworth mines, they provided sulfide ores. These were lead silver ores. They were also shipped in sacks in boxcars. So what we have is all of the lead arriving by boxcar for unloading. And again, manual hand unloading sack by sack into the storage bins. This building here was the storage bins And from the storage bins, they would be sampling, and again using a Wiesen sampler, but they would crush to 0.25 of an inch for the lead. Also, any addition and mixing of limestone and slag were added at this point in this building. From there, we went down into the far end of the building here, and we have I'll just go to the sunny side of this building so we can see it a little bit better. We have the starting of the lead process. So again, sintering was done with Dwight and Lloyd sintering machines to create fine ores. For the lead process, they double sintered. So this is getting the sulfur down to less than 2%. So again, you can imagine the amount of sulfur dioxide going up the stacks. After sintering, it was sent to the coke was added again. It was sent to the blast furnace, and each of the 4 blast furnaces could produce 230 tons per day of dross. From the blast furnaces, it was sent to drossing kettles where the lead was skimmed off. So we have the drossing plant roughly over here. And from the drossing plant, the lead was sent to a casting in an anode machine. And this building down in here is the anode machine building. And once the anodes were cast, they were loaded onto the narrow gauge railway in this building right here. And from the narrow gauge railway, they were taken from the smelter as anodes, and these are solid lead anodes, to the refinery at the top of the hill. Okay, this is 318. We've just coupled to the lead box cars. This is the lead refinery, and the box cars are carrying lead ingots. So we'll be taking these out of here and up to the yards. There's 4 box cars of lead ingots produced per day that have to be switched out. We'll add 4 new empty box cars in here later in the day. Okay, we're standing on the coke trestle, and we're viewing the box cars now, just coupling on the lead ore trestle. The first 4 box cars were the lead ingots that we picked up on the lead load track, and now we've just coupled on to 8 box cars that have been emptied of lead ore sacks. Okay, we're looking at the coke trestle here. The 4 box cars that are just reversing are our copper matte cars that we picked up. We're coupling to the empty coke cars here, 4 empty coke cars and 2 empty limestone cars. So this is coming off the trestle that coke and lime are unloaded on. So what did I learn about copper and lead operations and prototype? Well, the copper low-grade ore dump really had an impact on scheduled trains and extras in terms of the ability to keep all schedules moving through the junction. In a full day, we had to dump 36 car loads, and each of those car dumps, 3 of them, took 45 minutes. So it becomes quite a scheduling nightmare in making sure everything's running smoothly through the whole smelter junction. We had to spot 31 cars to the various leads during the day, and we had to yard 31 cars also during the day, which keeps the switcher busy full-time just within the smelter. So that's a lot of car movements in one day. Lastly, holding true to 1901 is difficult, as it was a very basic copper operation, just matte, and lead had just started, so it wasn't all sorted out yet. There's a tendency to wanting to build things that look good in the pictures or that you think should be there, but in fact when you actually get there, it was very basic, and I think that what I learned is I had to keep it very, very simple and accept that that's all that was there in 1901. So that wraps up our story of Smelter Junction in Trail BC in 1901. With that, we will depart here, yard engine number 318, and let it continue on with its switching duties for the day, and we will end the presentation and take questions. Thank you very much.